Hello everyone. The title of this video is section 3.6 on the vertical line test. So in this video I'm going to be going over the Knewton Alta assignment for section 3.6. Please know that the questions I see in this video are not necessarily going to be the same exact questions you're going to see when you work on the assignment yourself. But the objective will be the same, and the way I go about doing the problems will be the same. So hopefully this helps you when you're working on the assignment on your own. Okay. Oops, get the assignment. Alright, so here's the assignment page. Again, you will not see the word preview. You're just going to see the title of the assignment, the mastery bar, the objectives, and there is only one objective in this assignment. Just use the vertical line test, which I'll describe in a second, to determine if a graph represents a function. And then a question, and below it you have some buttons, feedback, if you want to send Knewton some feedback. You will not see the instructor cheat button, right, because you're not instructors, you're students. And the more instruction button, right, if you click on this when you're struggling with a question or an objective, they'll provide you with some reading material or videos that will hopefully help you working on that a question from that particular objective. Alright, so the first question, and I think like every question is going to be this because it's all the same objective, is determine whether the graph shown is the graph of a function. Alright, so I'm going to draw a rough sketch of this graph on a piece of paper, and we'll talk about the vertical line test. Alright, so what I've drawn here is a very rough sketch of the graph of the relation they gave us. So there are infinitely many ordered pairs, right? Infinitely many points in this relation. So hopefully you recall that for a function, right, in a function, every domain value, right, every value of the domain, which are going to be x coordinates, every value of the domain, which again are x values here, corresponds to exactly one value of the range. And the range is made up of, when we're talking graphs, will be y values, right, for ordered pairs. So hopefully you remember the definition of a function. Now, this vertical line test that's being talked about here in section 3.6 is a way to test whether or not a graph of a relation is a function. And the vertical line test says the following. Alright, here's how you perform it. If every vertical line, right, and vertical is straight up and down, like the y-axis is a vertical line. If every vertical line intersects our graph, intersects the graph or hits the graph, intersects the graph of a relation at most 1 point. So if I draw a vertical line, and you draw, any vertical line at all, and they hit the graph in at most 1 point, so that means it either doesn't hit the graph or hits the graph once, but never more than once, is all I'm saying here. Then the graph is the graph of a function. Then it is the graph of a function. That relation will be a function. Then it is the graph of a function. So this is the vertical line test. So you start drawing vertical lines. Now remember what the little arrows mean, right? The little arrow on the graph means, this is going this way forever in that direction. This is going this way forever in that direction, okay? Forever. So you start drawing vertical lines. So like, this is a vertical line. I'm just going to do them dashed, okay? And see how many times these vertical lines hit our graph. So this vertical line I just drew hits the graph 1 time. So that means that this x value, right, every vertical line will basically correspond to a single x value, a single value on the x-axis. So if a vertical line hits the graph 1 time, that means that that x value corresponds to 1 y value, right? So that vertical line hits the graph once, this vertical line hits the graph once, this vertical line hits the graph once, right? This vertical line would hit the graph 1 time. It looks to me, right, and obviously you can't draw every possible vertical line, but just by looks, it looks to me that every vertical line, right, every vertical line, which I could just represent by like the edge of a piece of paper here. I drag this piece of paper across, the edge of the piece of paper, that vertical line is never hitting the graph more than once. So that tells me that every x value either goes to no y value or 1 y value, but never more than 1. So this graph is the graph of a function. Right, so this is the graph of a function. This is a graph of a function. Right, the definition is satisfied. Every x value goes to 1. Every x value that's actually part of the graph, that's actually used, goes to 1 y value, and not more than 1. And that's it. Now, in order for a graph to be a function, every vertical line has to hit it either 0 times or 1 time. But for a graph to not be the graph of a function, you only need to find one vertical line that hits the graph more than once. Just one vertical line. If just one vertical line hits the graph more than once, then it's not the graph of a function. And I'm sure we'll see examples of that. All right, so going back here, we're just answering yes or no. And it looks to me like, again, just think of vertical lines, drag a vertical line across, and that vertical line will never hit this graph more than 1 time. So this is a function. And submit. Wonderful. All right, and again, please read answer explanations, whether you're right or wrong. Right? If you're correct, just read through them and make sure that the reason you got it correct is valid, right? That you didn't just get lucky. And especially if you're incorrect. If you're incorrect, read through the answer explanations and see if you can figure out why you went wrong, where you went wrong, and then maybe when you come across future questions in that objective, you'll do a little better. All right, so next question, same thing, same objective. Here is another graph. Now, I'll again draw a rough sketch of this on a piece of paper, and it looks like part of the curve goes to the right of this vertical line here and left of the vertical line there. So I'm going to try my best to draw again a rough sketch of this. So again, this is very rough, all right, very rough. Now it looks to me like I'll draw the same copy up here. It's doing something like this. It's like curving up, and then it's curving upward, and then starts curving downward. Right, more like that. There's this point here where it changes direction, called an inflection point, changes concavity. Don't worry about that word. So, all right, start drawing vertical lines. Now, obviously, all the vertical lines over here hit the graph one time, right? I don't have any vertical lines that are hitting the graph more than once over here. Same thing over here. All right, vertical lines over here are hitting the graph once. It's this area that's a little bit tricky. I draw a vertical line. Now again, I might have drawn the graph poorly, but it looks like I'm hitting the graph multiple times. But if we look back at the picture, it's curling up, reaches a point, and then curls again. I feel like this is one of those where this is to the left of the line, this is to the right of the line, and there's only the one point on the line. So I feel it looks to me like my drawing was pretty bad. It looks to me like this is a function, right? Based on this, all this to the left of that, all that to the right. There's only just the one point really, even though it looks like there's more than one. There's only the one point on that vertical line. So I would say this graph does represent a function. And just to be sure, I'll hit the instructor cheat button. Yeah, I got it right. Obviously you can't do that. All right, but yeah, so like it looks bad when I drew it by hand, but this stuff is all to the left of that point, this stuff's all to the right of that point, and every single vertical line hits the graph one time, and no more than one time. So this does represent a function. Great. Alright, so again, a little tricky there because my hand drawing was bad, but let's move on. Right, same thing. Same thing. Alright, so again, I'm going to draw a rough sketch by hand. It's just this like semicircle. Alright, something like this. Now, again, these vertical lines over here don't hit it, so they're not, you don't have to worry about those. This vertical line hits it once, this vertical line hits it once, this vertical line hits it once, this vertical line hits it once. It looks like every vertical line hits it at most once, and then all the vertical lines over here hit it zero times, right? But every vertical line hits it at most once, hits the graph at most once. Another way to say it too is that no part of the graph is above another part of the graph, right? Because if one part of the graph is above another part of the graph, then you're going to have vertical lines that hit it more than once. So again, I have a function. Right, this is again a function, the graph of a function. So I'll answer that. Right? Graph represents a function. Cool. All right, let's hope that one of these is not a function. Alright, this is a function as well. Alright, so that was all bad. Let me actually, or before I finish the assignment, let me show you an example of a graph that would not be a function. Alright, so let's pull up a new piece of paper here. I'm just going to make one up. I mean, a circle. Right, here's a graph of a circle. Now clearly, again, the x values, y values, look, this vertical line right here hits the graph twice. So, we found one vertical line, and that's all it takes. That's all it takes. If you can find just one vertical line that hits the graph more than once, then the graph is not the graph of a function. Alright. So I at least wanted to show you one example, even though it's not one of the problems I saw. But you might see something where, again, if any part of the graph is above another part, right? So if I had a graph that looked like this, like a sideways parabola, part of the graph is above another part of the graph, this would not pass the vertical line test, right? So that would also not be a function, right? So that's not a function, that's not a function. So again, I'm hoping that you can see, I'm hoping this is pretty easy, I feel, but you can very easily tell that there are this x value goes to two different y values, so it doesn't satisfy the definition of a function. But back here, just this curve right here, just starting from looks like -3 comma 0 and then curling up like this. Draw vertical lines. The vertical lines over here don't hit the graph. That's fine. And then any vertical line here, from here on out hits the graph just one time. So I can't find any vertical lines that hit the graph more than once. So yet again, this is a function. All right. And like I said, you will come across maybe, right? You will come across some graphs, like I showed you the circle or the sideways parabola or whatever. There will be graphs where there will be a vertical line that hits it more than once, and just know to state that that's not a function. Right? So just be careful. Alright, it looks like that's it for the version of the assignment I'm seeing. Again, the version of the assignment I see is not going to be the same as the version of the assignment you see. Alright, but please be aware, the objectives are the same. The way I would approach the problems, right? They're all vertical line test problems here. All those, the way I would approach them would be the same. So I'm hoping that watching me go through this helps you, when you're working on the assignment on your own. And thank you very much for watching.